Leatherwood here. This is your lesson for Thursday, January the 13th. If you'll go ahead and get your note-taking guide and get ready, we're going to be on the limiting reactants, and we're going to make it through the next 4 parts of your note-taking guide, and then you'll be finished with it. So we've got some practice we're going to do. So let's go ahead and start with limiting reactants. So basically all they are is they limit how much product that we're going to get. So the limiting reactant is one of them on the left side is going to run out and the reaction is going to stop. The other reactant is going to be an excess. There's too much of it, so you'll have it left over. And so the limiting reactant is completely consumed. Once the limiting reactant's consumed, the reaction stops and then anything else is left over. You can recognize a limiting reactant problem because there's more than one given amount. Convert all of your reactants to the same product. So any product you choose, if there's more than one on the product side. So you're going to have to take all the reactants on the left, whether you have 2, 3, 4, or 5 or whatever, and you're going to make picket fences for each of them and compare them to a product with the mole-to-mole ratio and see how much product you would get. And then the lowest answer is your correct answer. So whatever one's the lowest one is your limiting reactant because you can't go past that one. That's the most you can make. It's the smallest amount. And the other ones are in excess. So if you think about it, this makes sense if we look at the s'mores lab we did, right? So this was the equation we used. I know we only used 3 chocolate pieces, but that doesn't change anything for this. So if I gave you 6 extra marshmallows and I said, now how many can you make? Well, it doesn't really change anything, right? Because you still only have 2 graham crackers and 3 or 4 chocolate pieces. So all those marshmallows are just extra at this point. Because you're limited by the graham crackers and the chocolate pieces, you're going to use all of those up. And so the lowest amount you can make is 1 s'more. So that's why it's the limiting reagent. The lowest amount you can make is you can't go past that. So when we did the lab, you had a question that said, if I gave you this, find the limiting reactant and tell me how many s'mores you can make. So you had to make 3 picket fences, one with this, one with this, and one with this, and compare all to a s'more and figure out what the lowest number was. You should have gotten chocolate bars. So chocolate bars was the lowest one. That was going to be what you ran out of first. And then based on that, we could figure out everything else, right? So let's look at an example really quick, and then I'm going to work some on paper after this as you go through your note-taking guide. So make sure you get this one on your note-taking guide as well. So we have 10 grams of aluminum reacting with 35 grams of chlorine gas to produce aluminum chloride. Which one's limiting and how much product is produced? So you're going to have to do this in 2 steps. There's our equation. It's balanced there for us. So we're going to make our first picket fence with aluminum. So let's go and set up our fences. Remember, our given goes in the top left, which is 10 grams of aluminum. We're going to compare that with the molar mass. So 1 mole per the molar mass is 27. Our mole-to-mole ratio, we've got moles of aluminum is 2, and our moles of aluminum chloride is 2. And lastly, we're in moles of aluminum chloride now, but we want to know how much product we're getting. Luckily here we only have 1 product. So we compare that to the molar mass, and everything cancels out unit-wise, and we're left with 49.4 grams of aluminum chloride. Now we're going to use that same process for chlorine. So set up our picket fences, and we're going to do the same thing we just did, but for chlorine. So we start with 35 grams of chlorine. We convert that to moles using the molar mass. convert that to moles of aluminum chloride using the mole to mole ratio. We're just looking at coefficients there. And then converting it to grams by using molar mass. So you get 43.9 grams of aluminum chloride. So that is the most you could get. The least number is your limiting reactant because that's the most you could ever get. So that means chlorine is our limiting reactant, and this is how much product we could get. So that is going to be your answer there. So we're going to do a problem together on the next page, so make sure you're going along in your note-taking guide. We just did this problem here, and we're going to do these two next.